Daily work unit 1-4. Blank points determine a line. And we got to be kind of specific here. Remember that 1 point doesn't determine a line. There's infinite lines that can be drawn through that 1 point. But if we plot 2 points, only one line contains them. And so we would say that 2 points determine a line. Now, when we get to a plane, 1 point could have a plane coming this direction or that direction or that direction or that direction. Think about a slice going down through there, like a board going through, where you see each of those lines like a piece of plywood going through that point. So we didn't get a plane. If we take non-collinear points, if we made a board go that way, it hit those two. Our board go that way, it hit those two. Our board go this way, it hit those two. But if we're going to hit all three, we're going to have to lay the board flat, which means to hit three non-collinear points, there's only one way we can hit them with a board, and that would be to lay it flat down on all three. That's why a stool can have 3 legs and it won't tump over, right? Because those 3 points determine a flat surface. And so we say that 3 non-collinear points determine a plane. Now, to get a three-dimensional object, we would have to have those 3 non-collinear points, like the 3 legs or feet of the stool, but also the stool itself, right? To connect all of that, we would create a three-dimensional object like a triangular pyramid, see? And so for non-coplanar points determine space. We're going to let you answer some of these others by yourself. I wanted to definitely go through the first 3. 2 points determine a line. 3 non-collinear points determine a plane. 4 non-coplanar points determine space. And you can use the chart on the page before to answer the other questions. Now, I want to answer number 10, 11, and 12 because I want us to get the concept of dimension and stuff down, because this again connects to some things we're going to learn later about scaling up and scaling down. So a rectangle, which represents a plane, has 2 dimensions. It has length and width, right? And its area, like if it was 2 units by 4 units, we would say that its area is 8 square inches maybe. And so the area is represented by a power of 2 square units, you see. A segment has 1 dimension, which we call length. So if we had a segment, we might measure that in inches. 1 inches, 2 inches, 3 inches, 4 inches, 5 inches, 6 inches, 7 inches. So we might say that that is 7 inches long. Notice when we said inches, the exponent is an understood 1. So at 1 dimension, and its length is represented by a power of 1. A prism, which would look something like this, this would be a rectangular prism. Represents space. It's got 3 dimensions. It has the dimension length, the dimension width, and the dimension height. When we talk about volume, we're talking about cubic units. So we want to know how many of these little cubes would be in there if I can draw one decently for you here. So how many of those little cubic inches we could say, which is an inch by an inch by an inch, would fit into that rectangular prism. And so the volume is represented by a power of 3 cubic inches. Okay, and again, that will be repeated in the Algebra 1 text and in the geometry text toward the end of the book here. Okay? All right, so that's the Unit 1 for homework. After that are the odd answer solutions, and I might just kind of scan through this so that you know. All of the odd answers are at the end of the chapter, and they're not just given, they're actually worked out and explained, as you can see. So we're showing the work for all of the odd ones. So that's kind of handy to use as a reference also. There is a teacher's edition for teachers, and if your teacher's okay with you seeing that, then you could ask for that. You can see here where we're even getting into three-dimensional drawing some. And some of the things that I tried to go over with you, like if two lines intersect, exactly one plane contains them, or a line is determined by 2 points, a plane or space is determined by 4 non-coplanar points. I actually drew you a visual. Through any 3 collinear points, how many planes could you draw? And I didn't do a really good job a while ago trying to draw those planes, but I did a little bit better job of showing you like the fold of a textbook. And if you just fanned your textbook out, you'd have all those pages, which would represent a plane passing through the crease of the book, which would be like a line. So through 3 collinear points, there's an infinite number of planes that would pass by. So again, you can look at the odd answer solutions, and I may have done a little bit better job of drawing there than I did in the video because I was trying to maybe go a little bit faster in the video. Okay.